Last year, the Hackaday Prize began a movement.
This year, we're taking on problems that matter to everyone.
Thousands of hackers, designers, and engineers working on solutions.
We're not waiting for this to happen. We're making it happen.
Learn, share, teach, or explore.
And you could win the 2015 Hackaday Prize.
Even though you left.
How about that word? Tsunami. Last year, we put the call out to hardware hackers worldwide, and a tsunami of projects showed up. Good? Are we filming? Wait, I'm looking there and I'm looking here. Where am I looking?
Okay, you want to do that? Look at Jacob.
We put the call out to hardware hackers worldwide. We put the call out to okay, stop smiling.
Yeah, we started the Hackaday Prize to return balance to the universe.
The Hackaday Prize will go to projects that come up with a clever solution to important problems. I actually hate that line.
Everyone else keeps getting older. And I keep staying the same.
No.
Now we're going out to the desert where we're going to build some shit. So me, Brian, Mike, Jasmine, Alec, Matt, and Vilke and Rich. The world, it will not be the same tomorrow because we are making a moisture evaporator.
You can build something that reminds people to take their medicine, an automated garden, or an environmental monitoring.
Do that last time. Last time, we sent you to space. But this time, we want to make Earth an inviting place to return.
What's up? No, you can't hear anything out of this.
We're filming a launch video for the Hackaday Prize. It's going quite interesting because the camera stuff is getting learned right now. We are all learning how to be actors. We still didn't rehearse the lines, but we will soon. And Brian and I are sharing a sweaty spacesuit. It's like really weird.
We're running for the Hackaday Prize. It's chasing us.
There's so much talent out there in basements, garages, cubicles, offices. What if we all started thinking about simple builds and focused on real problems?
People want to spend their time doing something that matters. This is your chance. Choose an issue that affects the world or your community and start working on a building block that will pave a path of change.
They should build cool shit.
Yes, he has them. Hold on. Dude. Boy, that seems like a long time ago. But we had an amazing turnout this year. We had over 900 entries in the 2015 Hackaday Prize, and I think it says a lot about our community that people are willing to put their time into something that matters.
Pretty amazing. Thank you. So, shall we start?
I think we shall. So a little bit about the Hackaday Prize. The Hackaday Prize is our engineering initiative. We want to get people to take the creative energies that they use to explore things that maybe don't make a huge change in the world and apply them to something that does matter. And like I said, 900 entries, you can say to yourself, a lot of those weren't targeting problems that were affecting a huge swath of people. But I think getting people to actually think about problems and think about the skills that they have, start looking for others that they can combine those skills with and to really make a difference, it does make a big impact. So even just getting people to say, I'm going to document my hardware, I'm going to share some of my ideas as open design, makes a huge impact on the world indirectly. And as we'll see tonight, many of the projects are making a very direct impact on people's lives.
So the Hackaday Prize is presented by Westrom, and we had 5 amazing sponsors. We had Atwell, Freescale, Microchip, Mouser, and Texas Instruments, who helped to make this possible because they believe in this engineering initiative. They want to make the world a better place. So let's give them a hand.
So the impact of having partners like these companies that share the vision of Hackaday and share the vision that SupplyFrame has means that we were able to make the Hackaday Prize much, much bigger this year. We were able to go around the world to all kinds of different venues and actually get people who had only met each other online through Hackaday.io or other means a chance to meet in person. And what you're seeing tonight is the culmination of that. This is one of our largest events of the year, and as you can see, amazing people turn out. It's pretty hard to say that every single person you ran into today wasn't a fascinating conversation. It's the highest concentration of people you really want to talk to that you're going to see during the year. And it makes a big difference in building networks that allow people to do distributed engineering and to do projects where they don't have the talent or maybe the local talent to partner up with for these large-scale projects.
So this year we tried something new. Last year was the first year of the Hackaday Prize. This was the second. So we had a track called Best Product. And we decided to have something called Best Product because there were so many amazing entries in 2014 that we thought some of these things, some of these projects should turn into products and be out on the market for other people to enjoy. So you could opt in to the Best Product track, which meant that you needed to have 3 copies of your project. That's how we decided we would define that something was a product. It needed to be repeatable, it needed to be tested. We all know that's pretty hard to achieve. And after 3 months of the prize starting, we allowed people to opt in.
So on to the prizes. We had a total prize package of about $500,000 this year, which is quite incredible. So it's really, obviously, it's easy to celebrate the biggest of the prizes, but we actually moved a good chunk of that prize package earlier into the contest so that we could get things into people's hands that could help with their build. So we gave away things like tools and development boards and gift certificates to PCB companies like Osh Park and laser cut certificates for getting laser cut things, getting 3D printed materials so that if you didn't have a laser cutter or you didn't have a 3D printer and you needed to work on your case design for the Best Product Award, those were already into your hands. And we've had hundreds of winners through contests that we ran, through live events that we did, and a lot of the booty is already out in the hands of the hackers and has been in use for months. And I think that was a nice change this year. But of course, the grand prize is a trip into space. You can't get much bigger than that. And if you're not, the adventurous sort, you can opt to take a cash prize of $196,883 instead. This is a monster number. It's a fascinating math concept. You should look it up. And of course, as Sophie just mentioned, new this year is the Best Product Award, which offers a $100,000 cash prize. It offers a residency at the Supply Frame Design Lab in Pasadena, and it also offers some intros with other partners that might help take those products to the next level.
So we had 12 amazing judges this year. Probably. They were all chosen because they have all done really good engineering projects. We think they're engineering experts. We admire them. We are really grateful that 5 of them are here tonight. So we have Ben Krasnow.
All right, now we're going to take a look at just a brief overview of the 10 finalists and a few of the comments that the judges had after looking at their project and voting for a winner this year.
Our project is the Luca EV, and we're addressing the dual problems of pollution and energy storage. The Luca project was ambitious from the start. The car had to be cheap, fast, light, long range, and beautiful.
I really liked that one too. That's probably one of the most impressive builds, and his main addition to the EV sort of marquee is doing hub motors. And so it's funny, a while ago I wanted to build an EV myself, and I thought using hub motors would be the way to go because they're so much simpler. You don't need a transmission or a drivetrain or constant velocity joints or anything.
A common cause of cost explosion in commercially available solutions is design customization. To address this need without compromising affordability, we use parametric hand models derived from hand anthropometry studies to adjust our design to the needs of each individual. The only required parameters to personalize the design are the hand length and the hand breadth.
They actually went through and identified the problem, and the problem isn't that people don't have prosthetics. I mean, that's not the it's not really a solvable problem, right? They broke that down and they noticed that part of the problem is the actual mechanical mechanism that's designed to give the prosthetic all this extra configurability and freedom. That those parts are expensive, and then they designed this really ingenious mechanism that they tested in real-world scenarios step by step.
This is the beta prototype of my portable environmental monitor. This is a rugged aluminum enclosure that can fit the palm of your hand. You can see it has some holes. This is for the dust sensor. On the back it's the air quality sensor, the BMP 180 for pressure and temperature.
Yeah, this one's pretty ambitious. This is maybe one of the most ambitious ones because it relies on this large network of sensors. And so, yeah, if you distribute all these sensors, you can make a map of, pollution events and that sort of thing. And it sounds pretty cool. I think that having that sort of data available would be very useful for a lot of folks.
Steve Thomas has ALS and lost the ability to drive his own chair 2 years ago. I typed this voiceover using my eye gaze, and my computer is generating the voice that you're hearing. BallMatic is a simple addition to users' existing equipment that allows them to control their wheelchairs using only their eyes.
The eye-controlled wheelchair was just a really great example of taking a very personal but also very common problem and then designing something that's simple and easy for people to reproduce and well documented. And that was just really great to see.
In order to perform work safely and a rescue if needed, we use devices like this. It's a rugged little item. You clip it on your chest, but you can't get it any closer than your body to the area unless you resort to hanging it from things. You also can't see the display, and it's hard to even hear it if the thing is far away from you. Hence, the gas sensor being born.
I really like the form factor. So the project has like a rubber ball, so you just toss it into the environment that you want to inspect. I watched like the Chemical Safety Board YouTube channel, and it's actually a big problem. Workers will open like a manhole cover and not know what's going on. And then if they descend into the manhole cover, sometimes it's hard to get out in a hurry. So this would be like a perfect application for that sort of situation.
Dolby gives us the ability to see polarization, and its images can be used to locate landmines, identify cancerous tissues, see underwater, detect invisible pollutants, and who knows, maybe even observe cloaked UFOs. Inside the Dolby Universal Imager are two filter wheels rotated by standard hobby servos driven by an Adafruit servo hat for the Raspberry Pi 2.
I had a bit of a soft spot for the Dolby project, the polarization camera, just because that's something I've been interested in experimenting with on my own. So, that project seems like it's maybe more of a building block that I want to see other people improve on.
Sensor. So the two electrodes are here, and when I put them in water, let's switch the sensor, the reader on. When I put them in water, you'll see that the impedance immediately changes, and the deeper I put this in, now it gives me 100%, which is actually...
Yeah, that's another really great application. The angle is sort of reducing water use, and so if you dump water on the ground, you don't know if the water is, if it's soaking your plant to death because it's, soaked into the ground. And so I thought that the most innovative part of the project was actually the water sensor, which is like a couple of electrodes encased in plaster of Paris, and then you would put that in like a 4-foot deep hole. And so when that thing gets wet, the conductivity goes up.
This is my electrically enhanced wet scrubber. This technology can scrub out fine particulates and volatile organic compounds in buildings, and do so cheaply and effectively. This technology is highly scalable depending on the application you want to use it for. It could be a small countertop device, or you can scale it up to something like this size. Now this device would be more suitable as a centralized air cleaning unit for buildings and workshops.
I thought the concept was really cool. It potentially solves a huge problem in indoor air quality, especially in countries that really need it, like China and India, where they have just horrible outdoor air quality.
Introducing Farmbot, humanity's open source CNC farming machine. Farmbot plants seeds with millimeter accuracy and then waters them individually, the exact amount that each plant needs. Farmbot can grow a variety of crops all in the same area at the same time, and each plant is cared for in an optimized, automated way.
And so they currently have like two heads for the robot. One is like the seed planter and then the watering head. And then they said, well, this could be, you could put gas dispensing heads and like other liquid dispensing heads. And so I think the idea is that you would have kind of a test garden. So if you wanted to figure out like the ideal fertilizing schedule for a particular plant, you could, matrix this out and basically test that out.
My entry for the 2015 Hackaday Prize is a solar-powered utility vehicle, or SUV for short. I designed the vehicle for the work that I do in South Sudan. I needed a mobile workshop that would allow me to move from place to place and power tools when I got there. While I designed it for this specific purpose, I believe as a platform it could be useful in many other ways. Many of the areas in South Sudan where I live lack any sort of municipal power. In many rural areas, there's no source of power at all. Fuel is only available in limited areas, and even then, there are often shortages.
It's a really interesting project, and I like the fact that it came out of his own need, and he just kind of built it out of available materials. I think that's really that's really the spirit of hacking.
there, Ben, tap that.
Let's give another hand to Hackaday. I'm very honored to be selected as a judge, so thank you for wanting my opinion on this. It was a really, really great crop of projects and a very tough decision, but without further ado, we're going to start with the 5th prize. Oh, you want it?
What is the 5th prize?
Say what they win.
Oh, okay, sorry. She's telling me I have to read off the card. Okay.
There are rules.
That's placement, right, okay. The prize is a visit to the manufacturing epicenter of Shenzhen, China, while they meet and explore THP with THP judge Ian Lesmet.
Lene.
Or $5,000. The envelope, please.
Okay.
5th place is awarded to the Dolby Project.
Do you want to give him a mic?
Congratulations.
Thank you. Thank you very much.
Speech.
Thank you very much, and this was a great opportunity. In a way, I'm a little bit sad that I got a prize because I would have liked one of the younger guys to get it. I saw so many incredible projects this year that it must have been an incredibly difficult process to select it. But thank you very much for this. I hope that tomorrow you'll see some of the applications and start using some of the polarization imaging that I'll talk to you about tomorrow. Thank you.
So that was David Pucci of Dolby. I liked seeing his project, all the polarization. Okay. I don't need that. I have my own. Thank you. So I get to announce the 4th place winner. They get to tour CERN, home of the Large Hadron Collider. So trip to Switzerland plus all the cool stuff, or they can have $5,000. The 4th place winner is Eric Williams. He made the gas sensor for emergency workers.
Thank you very much for this. Thank you to the Hackaday staff for putting on such an awesome contest. All the sponsors there, guys, clap it up for them. Your hard work, and thank you to all you out there, guys. You guys are what make these happen. It doesn't get said enough that this is where we learn from, is everyone out there. We learn from each other, we share it back whenever we can. Thanks very much. Okay, 3rd place, the Builder Kit, offering a quartet of awesome tools. This is a combination of the Other Mill, the Taz 5 3D printer, the X-Car router, and a Grizzly bench lathe. For $10,000. And the winner is the light electric utility vehicle.
Unfortunately, Chris Lowe is in South Sudan again. But he sent us a video.
Hey everybody. Sorry I couldn't be there in person. I'm up in Ida refugee camp on the border of Sudan and North Sudan. Just wanted to say thank you to Hackaday and their sponsors, as well as the Hackaday community. I really love being a part of this community and learning from everybody. Just want to thank you for putting on this competition. There were some really great contestants and some really great projects, some of which I would really like to explore further. I got some really good ideas from people. So I just want to say thank you. The project itself has been really useful up here. I've been using the power from it to modify this shipping container to turn into a house. It's just been really nice to not have to use a generator and petrol and everything like that, and be able to weld and use tools. The vehicle itself broke free when I was driving it here when it was getting shipped, and so it took some structural damage, so it's not driving at the moment, but I've already got some plans to improve it and make it more robust and more efficient. So just thank you for putting on this competition. I'm really happy to be a part of it. Thanks to the judges for seeing value in this project. Yeah, just thanks a lot, and God bless.
So that was third place. The second place winner gets a 3x25 90-watt CO2 laser cutter or $10,000. But which would you rather have? And the second place winner is Open Bionics.
Imagine that we would make it so far, so we're already, I cannot even find my words. So thank you very much. Thank you very much, guys. I hope that we will have many collaborations in the future. Open Bionics starts now, as I told also in my presentation. It's a great honor for Iris. Iris is for second year a finalist. Thank you.
Going to tell you yet.
We're going to play a video.
We're going to play a video?
Yeah.
All right.
Let's hear it for Alicia White and Ben Krasnov, judges of the Hackaday Prize. So we have 2 prizes left to award.
Let's just have another round for to award the Best Product Prize and the grand prize, the trip to space.
We're going to take a look at the 10 finalists for Best Product.
The subpos node transmits its program location to a client device through beacon stuffing. With this information, you can trilaterate your position from one or more nodes within a building. Several nodes have been created to provide a calibrated and easy to configure device for anyone wanting to enable positioning indoors. Current testing from these nodes has shown positioning accuracy results of up to plus or minus half a meter.
So people write to us all the time and say, I need a locator. I need something that is going to figure out where a thing is in my office or my warehouse or out on this field I'm planting. They want to know really precisely where things are, often indoors in ways that we can't really give them a good solution for right now.
So the PDP in a nutshell. It's a replica of the PDP-8, which was the most popular mini computer in the 60s and early 70s. It shows much better than modern computers how computers work at a low level. It also shows where we came from in terms of computer history. And it's a nice contrast of concise programming versus today's bloatware.
But the craftsmanship of this thing blew me out of the water. Looking at the case, the buttons, and all the LED work and the documentation of this project, I found that one highly compelling.
We at NeuroTinker are here to change that with our NeuroBytes technology that lets students and lifelong learners learn about the nervous system by building their own nervous systems.
Trying to get them to communicate and see how they interacted, it was really fun.
We make a thing that looked a lot like a knee with a reflex when you tapped it, and it was just the coolest thing. It's sort of like little bits for analog, or little bits for neural networks, more to the point. It's a very unusual kind of a thing. It's not the analog or the digital that I'm used to. It's really a different kind of system.
We created a hand drive wheelchair attachment that can attach to any wheelchair, and it allows it to be powered in a rowing motion. That's good because it allows the user to sit up straighter, it uses bigger muscle groups, and it also keeps their hands cleaner. Traditionally, lever-powered wheelchairs come as like an all-inclusive kit, meaning that they're built into the chair. But because our hand drive wheelchair attachment is entirely 3D printed and completely open source, our hand drive can fit on any chair.
So you've got the two handles, and you've got what appears to be a brake handle on each one of the handles. And at first you're thinking like, oh, that's how, you know, you're gonna run like that, right? But then you pull the thing and it actually reverses the ratchet so you can go backwards.
Tipsy really lowers the entry barrier for programmable logic. It's really small, it's easy to grasp, and that's also the reason why I started using Tipsy. I had no prior experience with programmable logic, and I found it very easy to use. You can use any existing simulator software that you like to simulate your ideas and your designs, and once you are satisfied with them, you can use Lattice's IceCube software to compile your design into a bitmap for the Tipsy.
So I love the idea of FPGAs in DIP packages. There are a few of them out there, but this is like the smallest little FPGA that you could get your little hands on.
Backed with powerful sensors capable of detecting both the chemical and the physical harmful factors, URAD Monitor is an example of a complex piece of technology driven by motivation to help people solve the pollution problem.
You could have like real-time environmental information everywhere, which as far as environmental interests are concerned, that's the holy grail. What's going on over there? What data do we have from this? I mean, it removes politics entirely from the environmental equation, because you've got all the numbers and everyone can see them. There's no arguing.
In order to determine how much water is in the soil, I connect this meter to various sensors, and by activating the meter, I can actually read how much water is in the soil. In this case, the moisture is 74%, enough for this vine.
Very elegant design, right? There's not a lot to it, but the functionality is, in its simplicity, is quite impressive. You put like a variety of sensors at different depths, and you can tell exactly how much water is in each depth. And so you get a better feedback loop about how much water is in the ground. You save water in that manner, which is good for the environment, it's good for our fresh water supply, and it's good for the vines.
I am Abhishek, and this is Beagle Logic, which turns your beagle bone into a logic analyzer. Now, when I begin capture, you see that it requests the amount of data, and there is your captured data. So this is the clock, this is the serial data, and this is a word select line because I've captured an I2S bus here.
It's neat for a project to be taking advantage of the really high speed I/O on the beagle bone. I've seen a few other kinds of projects do that, and this is a neat kind of an attempt to make a clean and neat logic analyzer accessory out of that.
The thermal connector solders directly to the bottom of the chip through a hole in the PCB. After soldering, this heatsink is designed to screw on from the bottom side. So this chip, this small chip, is directly coupled to this really large heatsink.
You don't have a whole lot of options for yanking heat off of a small IC. you've got like, a little piece of adhesive and you stick a heat sink on it and that's supposed to make all of your heat problems go away. This one is like, how about we do something on the other end, we put a hole through it and then this cool looking round. I dug it. I dug BallMatic. I think there's a future for that.
Oh, this was a great thing that did pretty much one thing, right? It told you how much sun you got. It had a few other little sensors.
I think they had a firmware version that played Tetris or something. I don't remember what the game was.
That was hilarious. I think it might have been Pac-Man.
Pac-Man? I don't remember. I'm sorry. This was a really nicely packaged thing, a great little 3D printed case and designed to look and feel like a real product. I sunburn really easily. I can be outside for a total of about 10 minutes on a sunny day without getting sunburned. So when I'm at an outdoor event, and this means Maker Faire and everything else, I'm always darting between shadows. So having something like this would actually be personally useful to me.
This year. The core to doing this was that the people who entered the best product round, they gave us 3 versions of their product. We got 33 products in the first round of this. That's a lot of people who were able to take their product and make it into work 3 times. So there were 4 people from the Hackaday staff that tested the first round before we sent it on to Lenore, Riddell, and Pete. 7 out of 10 best product finalists are here tonight.
I think the thing is, in this age of hardware passion, everyone really needs to learn the role of product engineer, and I think this is a really important initiative to get people to start thinking that way.
Thinking about making things that last and taking stuff from being a prototype and making something that works once into working more than once and over again so that everybody can enjoy it. So with that, let's call Pete, Lenore, and Wendell up.
Lenore and Wendell are co-founders of EvilMad Science Laboratories, and Pete is the Chief Engineer of SparkFun, Director of Engineering at SparkFun.
This was a really hard thing to judge.
And our deepest respect goes out to all of the contestants that you actually got product in our hands to play with, and we got to, try our best to break it and use it. So thank you for sending those out to us.
The winner of the Best Product Award will receive a cash prize of $100,000. Along with the lab and assistance of introductions to organizations key to taking your product to market.
Okay, so in the envelope, the best product winner is...
Rainier Vanderlee with the Vinduino.
Wow, who would have thought that? I'm a little surprised and amazed. I was already honored to be a part of this community and making it to the top 10. And I was hoping for that trip to Shenzhen, but you see me? So I got a lot more, and yeah, this is incredible. So this will. I didn't expect this, so I didn't rehearse this speech. But yeah, we're going to make this work. We're going to make this Vinduino handheld product a real product, and bring it to the people that profit from it most. I was thinking of farmers in California first, but there's 36 countries actually that are in a permanent state of drought. So I will definitely reach out to other organizations and see how we can make this a success. And it doesn't take a lot of money to make this product. When I did the calculations based on my purchase prices, I came up on $25. The sensors are $1 or less. And if you make it in volume, it's even lower cost. So you can reach out to a lot of people that don't have the resources to really optimize irrigation and improve their yield. And basically, farmers grow food, so it's important. It's not just about saving water; it's about food as well. Thank you.
Yeah, come on up.
Okay, we'd like to announce the grand prize. This is, of course, the trip to space. I didn't forget it this time. Or a cash prize of $196,883, which is a monster number. And so that's not just a big number, it's actually a monster number. So search for that and
Monstrous.
learn some monster number.
Monster number.
Yeah.
But monstrous is funnier.
Monster
Anyway.
number.
Before I open the envelope and give you all what you've been waiting so patiently for, I too have to say Hackaday has done a great job helping improve the world. Thank you. This one made me cry. So the grand prize winner is the BallMatic, which was just amazing.
Wow, we've made it into the top 5. That's totally crazy. Thank you. It's a bit weird doing this video because it's actually Tuesday today and we haven't won anything at all yet. But if you're watching this, then really we have. Confusing. However, if we haven't, then nobody is watching, and I'm talking to myself, which is a shame, because I'd like to thank Hackaday anyway. This competition has encouraged, motivated, and generally driven the BallMatic project forward at a breakneck pace. It's been a lot of fun, and has already given independent mobility to 3 people who otherwise would not have had it. Thank you, Hackaday. Thank you.
So I told them that they were in the top 5. I didn't tell them that they had won, and I'm going to Skype them as soon as we're done here. It's 3 o'clock in the morning there right now, and so none of them could be Skyping because they're sleeping. Which was also the case with Chris in Sudan, and he has bad internet. So we told them. Thanks very much for coming. Can we get some Hackaday people up here who worked on this amazing event and on the prize and everything? Adam, Chris, Jasmine, Mike, Joshua. Can we also get the best product finalist? Any finalist that's here for Hackaday Prize, come on up.
I want to take one more
Steve, Alex.
Thank you. It's an honor to be a part of it.
Flag is here.
He's taking pictures. Snuggle in, guys.
Yeah, he's right there. Who else we got? We have room, more room. Anyone who worked on the prize, come on up. Matt. What are you doing? Get up here.
Hurry up, Matt.
Matt likes to make an entrance.
Where's Rich? Rich.
Taking the photo.
All right. Woo!
Thank you very much.
And the judges.
Okay.
And also then food.
Okay.
Thank you for being here.
One more thank you. I want to say thank you one more time to Supply Frame for this amazing party and for 5 sponsors for sponsoring the Hackaday Prize and believing in this and believing in us. And we're going to be having dinner arriving, I think. Is it there? I see food. Yes, there's food. And badge modding. Thank you also to the judges.